Hello, everybody. Thank you for tuning into the HOTH 9 workshop series. My name is Anakin. I'm an intern at ACM Hack, and today I'm going to be teaching about Intro to Backend Servers. So for those of you following the video tutorial, the link to the slides and the link to the GitHub README are here. And once you get to the slides, you can also access the README through clicking the link in the bottom left corner. And that has a detailed written guide about what we'll be doing today, as well as some example code that you can look at for the demo later. So before we begin, the topic we'll be talking about, which is backend servers, is a little bit of an advanced topic. So there are some prerequisites for knowledge going into this workshop. You should have some programming background. For example, you should know about if statements, for loops, arrays, and functions. If you took CS 30 or 31 or PIC 10A, then you should be able to follow along with this workshop. And knowledge of JavaScript is helpful, but not required, as I'll be explaining most of the quirks of JavaScript that we'll be using later in the demo. And knowledge of web APIs is also highly recommended. There is an entire workshop done by another hack intern about APIs that you can look at, but it's also not completely necessary, as I'll be giving a description of web APIs and how to use them. So what we'll be going over to get you on your way to making your own backend server is, first, we're going to learn about servers and what they are, and then we'll learn about APIs, HTTP request responses, and status codes, and then we'll get into the coding demo. So don't worry about if you don't know what any of those things are. We'll be going over everything in relatively fine detail in a moment here. So first, what is a backend? So if you've done web development before, or you've just heard people talking about coding, you've probably heard people use terms like front end and back end a lot. And basically the difference is the front end is what users see and interact with, like a button on a website, and is usually done in HTML, CSS, and JavaScript. And people refer to the front end as being client side. So the back end works with the front end, and it is the brains behind the scenes that serves the data to the front end and essentially allows the app to function. And it talks to the front end through something called the API. And the back end is commonly referred to as the server side. And as you can see in the graphic on the right, the front end, everything that the user sees is just the tip of the iceberg. Like many apps like YouTube, Facebook, the functionality that goes with them is really complicated, and the back end makes up the majority of the functionality for those applications, and it's something that the user never sees as well. And as you can see there, the API connects the front end to the back end. So what is a server? Well, a server is this guy, but in reality, like a server at a restaurant, a server in terms of computer science takes data and sends it out to various computers. For example, in real life, a server room would probably look something like this. And these are just a bunch of computers running some sort of code that will take information and send it out from the centralized server to a bunch of different computers, so other people all around the world can access your app. But how can we share content with many different people? So the way that a server works can be summed up with this graphic here. Let's say that the computer on the right is the Reddit server, and then in between we have the internet, which is a cloud that connects all of the clients. So the clients are the people using the app, and you have the person on top using the laptop who comments or who makes a Reddit post that says "rip dogwood," dog emoji, tree emoji, fire emoji. And now, if there was no server, nobody would be able to see this post, so it would be absolutely pointless. Therefore, when this user posts, the data from the Reddit post is sent over the internet to the server, where it can then be sent back to the other clients on their phone and the other guy on the desktop. So the person on the phone can upvote the post, and the fact that they upvoted will also be sent back to the server. And then another user can comment, "My bad for leaving my mixtape in the dryer." And that will also be sent to the server, where everyone else can view the upvotes in the comments. So without a server, we can't have interaction between multiple clients like this. So why should you use a server for your project? A server could be helpful if you want to share data between different users, such as if you're making a game, if you want to share a leaderboard between the different users, that's one possible use case. If you want to have users interact with each other, either through posts, like social media posts, as I described before, or through real-time chat, you would want to use a server, or if you want to store and update data. So that brings us to APIs now, which is how servers actually communicate their data to the client. And you can think of an API kind of like the steering wheel and the dashboard of a car. Like when you're driving a car, you turn the steering wheel to the left and the car turns left. And in between there, something happens with the gears and the electronics, and something goes on in the engine and it turns the wheel in some way that makes the car turn exactly how you want it to. But you don't need to know how that happened. And you might not necessarily know why the car works the way it does, but that doesn't mean that you can't drive a car. And that's essentially what the API is. It's something that lets us access the functionality of the server. So it's a piece of software that lets us access the functionalities of the server without necessarily having to know how the server works. So API stands for Application Programming Interface, and it's the code that helps our client and server communicate. And one important thing is that the client and server must agree on the format of the API. So for example, the client will expects the server to send it data in a certain format, like a text file, and the server expects the same from the client. And if these don't match up, then the API won't work properly. And there's some different API architectures. The one that we'll be using in this workshop is called REST, which stands for Representational State Transfer. You don't need to know about the other types or necessarily exactly what REST means, but if you're looking to put something on your resume, you can say that you learned REST. So next, we're going to go over how to interact with an API. The way that APIs are interacted with is through requests and responses. And the set of rules that clients and servers use to communicate is called Hypertext Transfer Protocol, or HTTP. And it works with the client sending a request to the server, and then the server returns a response to the client. Usually that would contain the data that the client requested. So the two common types of request types are GET requests, which retrieve specific data, and POST requests, which submit data to the server at a specified URL. So there's many different types of requests, and I left a link to the Mozilla developer guide so you can see all the different kinds of HTTP methods, but GET and POST are definitely the most common ones. You'll use them 90% of the time, and especially GET. So let's look at the anatomy of a request. So requests are made out of two parts. First is the header, and the header contains the method, the endpoint, and additional headers. So the method is just a type of request, like we talked about before. It can be a GET request or a POST request. The endpoint is just a fancy way to say the URL that we're sending the request to. And the additional headers just contain information about the client, like what operating system they're running, what time the request was sent, and things like that. And then in the case of a POST request, the body will contain the data that we want to send to the server. And so GET requests have no bodies. This is an important distinguishing factor between the GET request and the POST request, because the GET request does not need to send data to the server. It's specifically trying to request data from the server. So on the right here, we have an example of what a request would look like. This is, as we can see, the method is a GET request, and the URL is being sent to this super long path over here. And it tells what kind of encodings it accepts and the additional heading, what kind of languages it accepts, the refer. So this is telling us that this request came from twitter.com. And yeah, and it shows that I'm running Windows. So now we're going to look at responses. Responses, similarly to requests, contain a header and a body. So a response will contain a status code in the header that indicates status or failure. For example, 200 would mean that your request was successful. 404, you may have seen that before, is a request failure. 404, page not found. And additional headers would contain info about the server or the kind of content that's being returned in the response. And responses will have a body that contains the data sent by the server. And this data could be in multiple formats. For example, HTML, JSON, which we'll get into, plain text, or it could even send an image back. So as we can see, in this in this example of a response here, the server actually returned a JavaScript file. So the response body contains code. And that's another way that responses or that requests and responses can interact. So now let's look at some requests ourselves. And we're going to do this using the Chrome developer tools. And I've left a link here on the slides if you want to familiarize yourself with those more. So what we're going to do is we're just going to head over to a website like Twitter. And yeah, the sign up page is fine. And we're just going to right click on the website anywhere and click inspect element or inspect. And now it'll bring up a window like this with all the HTML and CSS for the website. And now if we look at the top here, we can click this tab that says network. And if we refresh the page, then now it'll show us all the incoming and outgoing requests made by this website. And we can see here, for example, if we click like, I don't know, it doesn't really matter. We'll just click like something here. We can see in the headers that this was a GET request, and this was the request URL right here. And the status code was 200, so we know that our request worked. And we can get a preview here, and we can see that this request returns some JavaScript. And if we look at another request, we can see that this was also a GET request. This one, status 200, it also worked properly. And the request URL was this right here. So yeah, that's how you can look at requests in your browser. And now I've been talking a lot about how 200 is good, and we've been seeing a lot of 200. So I'm just gonna give you a little overview of status codes in general. So the status codes of the 200s, like 200, mean that everything is good, your request worked. Status codes in the 400s mean that you made a mistake in your request that caused the response to fail. And status codes in the 500s mean that the server is broken, maybe it went down or something, and it can't fulfill your request. So now, what if you want to make your own request? So the first thing we're going to need is the URL that we're going to make the request to. So in this case, we're going to be using the Fruityvice API. And as we can see, we have the URL to the API here, and that's where we will be making a request. And this denotes the endpoint, which tells the server what information we need, and is just a fancy name for the URL. And if we make this request, then we'll get a response that looks like this. So in the response, we can see that it looks like some sort of text that contains all the information about the apple, which we requested. And this kind of response format is called JSON. So JSON stands for JavaScript Object Notation, and it uses a key value syntax. So basically the key is always a string that just gives a name for the variable that we're trying to access. And the value can be anything. It can be another string, like in this case, the name is apple, and apple is another string. So the key is a string, the value is a string in that case, or it can be an integer, like for the ID, the value is 6, or you can even have another object inside an object. So the curly braces here denote an object, and we can see that inside the nutritions key, the value is actually another object here, as denoted by these curly braces, and it has a bunch of keys with values of their own. And so in JSON, all you have to remember is that the curly braces mark where the objects are. The key is always a string and is followed by a colon. And then you have the value, which can be any kind of data. And then you use a comma to separate the different elements inside of your JSON. So now we're going to try this request in our browser. You can go ahead and do this too. And what you'll see if you paste this in your URL bar is that we'll actually see the exact JSON data that we expected when we do a GET request on this API. So yeah, when you paste something to the browser like this, it's just going to do a GET request, and you're going to get back the data in JSON format. So how can we make our own server then? So there's many different ways to make our own server. The most popular ways to do it involve using Node.js and Express, or Python and Django. Node.js and Express means that we will be coding in JavaScript. So that's what we're going to be using in our demo, actually. Unfortunately, maybe I'll do a Django demo later. But to get started with Node, what you're going to do is first make sure that you have VS Code or an editor of your choice downloaded, and you're going to need node.js to run your JavaScript, and you're going to need Postman in order to test out your requests. And if you're wondering what the difference is between JavaScript, Node, and Express, JavaScript is just the language that we'll be coding in. Node lets us run the JavaScript code, and Express is a library for JavaScript that gives us all the functionalities we need to actually code up a server. So yeah, go ahead and take a second to pause the video and get this set up if you don't have it already. And next, we're going to go on with the coding demo. And again, the entire demo will be on GitHub. You can access it on the link on the bottom left. And what we're going to be making is we're going to be making a server that implements various functionalities to do with Mad Libs. For example, filling out a Mad Lib, getting a random word of a certain part of speech. And if you don't know what a Mad Lib is like this game right here in the middle of the screen where you just have a sentence with blanks and little prompts. And it's up to you to fill out the blanks to make funny sentences. So yeah, I'll see you in the demo. Hello again, and congratulations for making it this far. We're now going to begin the coding demo section of this workshop. So the first thing you're going to want to do is you're going to want to create a new empty folder for your project. I'm just going to call mine Mad Libs. And if you're using VS Code now, you can right-click your folder and click Open with Code, and it'll automatically open up a project in that directory. Or if that option doesn't appear for you, you can always do File, Open Folder, and find the folder manually like that. So the first thing we got to do is we have to do a little bit of setup. So to set up, the first thing we're going to do is at the top here, we're going to click Terminal, New Terminal, and that'll open up a text window at the bottom of our screen where we can start typing commands. So in order to make sure that Node installed correctly, we can type the command node version like this. And if you see a version number, for me 16.13.1, then that means that everything should be working and you're ready to start. So now we're going to use npm, which stands for Node Package Manager, to install a few libraries that we'll need. So the first one we'll need is Express. So you can type npm install Express. And oh, sorry, before you do that, you're going to want to type npm init to initialize your project. And it'll give you a bunch of options that you can just press enter to skip through. They're all optional, or you can fill them out if you like. But now that you've done that, you can do npm install Express. And you'll see that we have this node modules folder, which contains all the code from the libraries that we've installed. And we also have these package and packagelock.json files, which basically lets npm know what packages are required to run this project. So somebody in the future, they can just type npm install like that. And I just press Control-C to stop it because I don't actually want to do that right now. But you can just type npm install, and it'll automatically install all those packages for you in the future. So next, I'm going to get cores, npm install cores, which will allow our website to be accessed from computers outside our network so we can share our app with the world. And last, you want to do npm install -g nodemon. And the -g makes it global. Instead of installing in our node modules here local to our project, it'll install for a whole computer so that we can use the nodemon command to run our server later. So once you have that all set up, you want to right click in the Explorer here, and you can click New File, and you want to call it server.js. And now we're going to start writing the code to make our server work. So the first thing we're going to do is we're going to declare a variable called Express, and we're going to require that this Express package exists, because that is what we're going to be using for all of our backend functionality. And then we want a variable called app that we can use to refer to our server. And we're going to define the port that our server will run on as 8000. And now if we do app.listen, then we can test to see if our server worked. So this app.listen takes two parameters. One is the port and one is a function. And for those of you who aren't familiar with JavaScript, one way you can define a function in JavaScript is by putting a parentheses, and inside goes the parameters, and then equals and greater, which is the fat arrow notation, and then put the braces here. And this is equivalent to saying, like, for example, like function like start. You could perfectly well replace this function with something like this, but this notation just allows us to have nameless functions in JavaScript. So yeah, that's something to get used to. And then this function takes no parameters, and we can just console.log backtick server listening on, and then $, open close curly brace, and port. So this backtick notation here in Java allows us, or in JavaScript, allows us to make formatted strings. So if you've taken CS31, you may be familiar with this operator for combining strings, or if you know Java or other languages, you may be familiar with using the plus operator. But in JavaScript, one thing that you can do is if you use a backtick to wrap your string, then you can just use this $ curly brace notation with the name of the variable inside to directly insert variables into your string, which is extremely helpful. So now we can run our server using nodemon server.js. Oh, sorry. Nodemon server.js. And we'll see that it says server listening on 8000. And to make this more clear, we can say server listening on port 8000. And what you'll see is that the server immediately restarted when I saved my changes, and that's thanks to nodemon. If we just ran the server normally, like this, using the node command, then let's say I wanted to change something, like no longer capitalizing this S, we wouldn't immediately see that change take effect. We'd have to stop the server. And by the way, in the terminal, you can just use Control-C to stop any process that's running. And then you'd have to rerun the server to see your change. So by using nodemon, we are able to see our code update in real time, which is really helpful. So now that we have our server set up, the thing is though that we have no endpoints, so we can't actually access the server or get any data from it. So the first thing we're going to do is we're going to set up a little test endpoint just to make sure that everything is working. And we can do that like this by using app.get /test, and get takes a string and a function as a parameter. And basically what this does here is this is saying that we want to define a new request. It'll be of type get request, and it'll be to this URL /test. And then basically whenever somebody visits your website and goes to the /test endpoint, it'll just call this function right here. So the format for handling endpoints in Express is just like this. You can do app.method, and then you have the URL and the function. So the method is just the type of request, like get or post. The URL is just it's the endpoint that we want to use. So for example, like /test, like words, something like that. And then the function is just a regular JavaScript function that gets called whenever this endpoint is hit. And by hit, I just mean whenever somebody goes to that endpoint, for example, in their browser. So now we can use the response to send a status code 200. So this is an HTTP response. We can add a status code 200 to say that our request worked, and we can just send a little bit of text back. And once we have all this saved, if you open up your browser, you can access your server at localhost:8000. You may see that 8000 is the port number that we defined here. So this is localhost : the port number. And then we can go /test, and we'll see that everything is working. So now that we have our server all set up, what we can do is we can start working on the actual Madlibs part of the project. So the first thing I'm going to do for that is I'm just going to define an object here. And this is just to get the demo to work. We're going to have words of different parts of speech, like apple, bicycle, mittens for nouns. And something you may notice here is that what I'm doing to define this JavaScript object is, in fact, very similar to the JSON notation that we looked at earlier, because they're basically the same thing. And so on the left, I have the keys, and on the left of the colon is the keys, and on the right of the colon is the value. And in this case, the value is in the form of a list, because the value can be of any data type. And on the right, you can see that I don't have to wrap my keys in quotes or anything, because it already knows it's supposed to be a string. It already works like this. Yeah, so now I have that object all set up. And if you want to access some property of an object in JavaScript, so we can use console.log to print to the console, and then we can use words.key. For example, words.noun. And we see it prints apple, bicycle, mittens. And we can also, we can do words.verb, and we'll see meditate.boogie and explode. And if we want to access a specific word within that list of words, we can use the index, for example, words.verb1, and we see boogie. And that's pretty much how you use objects in JavaScript. Extremely straightforward. If you've worked with hash maps or dictionaries in other programming languages, then you already understand this concept. So the next thing we're going to do is we're going to define an endpoint for getting a random word. And we're going to call it /words, and this takes the request and the response. And within the words endpoint, what we're going to do is we're just going to send all the words we have so that we can see that the data was properly stored on the server. So if we change this /test to /words in our browser, you can now see oh, sorry. I accidentally shortened the variable name here. So now you can see that we have a JavaScript object here, and it has all of our expected data. So we know that everything is working. So now we're going to do a little bit more of a complicated GET request. And now what we're going to do is we're going to make an endpoint for getting a random word of a specific part of speech. And how we're going to do that is like this. Now, what is this colon here? So one thing that Express allows us to do is, and besides just having regular strings or regular endpoints like this, we can have endpoints with parameters in them. So for example, if I were to go to random like this, /random, I could then put something behind here like verb, and this will, Express will know that whatever I put after the slash is in fact passed in as a variable. So this part of speech here, we can actually use it as a regular JavaScript variable like so. There we go. So we can do something like this to get this part of speech from the request parameters. And that allows us to have URLs that aren't necessarily set in stone, but rather we can change the behavior of our API based on the parameters that the user passes in through the URL. And if you're not familiar with this, this is object destructuring in JavaScript. You can, if you aren't familiar with the syntax, you can also do something like this. and just access the key like a normal object, like part of speech. And this works exactly the same. So you don't have to worry about object destructuring if you're not familiar with it, but I would highly suggest looking at the Intro to JavaScript workshop if you want to learn more about that. So now what we're going to do is we're going to get one specific list from our part of speech object. And we're going to check to see if that part really exists. And so once we get our specific list of the part of speech we want, we can check if the parameter that the user actually passed in was valid. And by putting the exclamation mark in front, if this list does not exist, then this words apart variable will be undefined. And therefore if we say not words apart using the exclamation mark, then we can check if this isn't defined. Then we can send a 400 status code with an error. We can send with it, we can have an error, and then we can return to immediately exit out of this function. And now what we want to do is we just want to get a random variable or a random index in this array, which can be done like so. And then since everything was successful, we can send back us 200 status code with our random word. So if you're not sure what this does, math.random returns a random number between 0 and 1, where 0 is included and 1 is not. So and by multiplying it by words apart.length, we can encompass the entire array. So for example, if the length is 3 and math.random returns 0.5, when we multiply by 3, we would get 1.5. And then by flooring that, we would get the index, which is 1, because we can't have decimals as indices. So now if we were to go to this endpoint, we can see that we get a random noun as expected. If we change this to verb, we get a random verb. And if we put something random, then we'll see the expected error. Error no part of speech matching ASDF, just as we coded. So that's how you do routing with parameters. That's what this is called. Defining all these endpoints here. You'll hear people refer to that as routing. And the next, we're going to do something a little bit more complicated. We're going to work on a post request now. So now we're going to move on to the post request part of the demonstration. And the difference between post requests and get requests is that post requests have a body, while get requests do not. So in order to make the post request, we can use the same format as before with app.post, the method, and we can define the URL as /fill, because what this request is going to do is fill in a madlib. And what I mean by that is, for example, if the user passes in a body of text like this, what our post request should do is that it should replace the part of speech between these bars with a random word from the list and then return that finished result to the user. So the first thing we can do is we can use the same object destructuring from before, or you can just use dot notation to get the body of the request. And basically what this will do is that if, for example, we have a JSON object, or if our request body looks like this, and inside of it we have text, then this code here will allow us to get this key or get the value of this key out of the body. And now what we're going to do is, just like before, we have to check to make sure that their input is valid. Sorry, the status code goes here. Error, and we can say error, no text field found in body if we were unable to get that key. And now we just want to exit out immediately if that didn't work. And now we can define a new variable with an empty string for the result that we're going to return. And now we're going to split our input string by the bars. So basically what this split function does is wherever JavaScript sees a bar in the string that it's given, it will make this a new element inside of a list and remove the bar. So for example, if we split the text from earlier, so if this is our string and we want to split that, then the output would be a list like this. I am, and then noun, because the split operator creates new list elements at the bar, or this could be any element that or any character that you pass in here. It's called the delimiter. So at the delimiter, we will end this list element and create a new one, and that'll allow us to more easily handle our pieces of text, which we'll call them tokens, and we'll iterate through the list like this. So this is just a fancy way to go through every single element in the list, and basically at every index we can access the value there by using this variable named token. And if you've used for each loops before in other programming languages, this is pretty much the same thing. In JavaScript, the syntax is like this. And now we're going to check we can just use an if statement and triple equals to check if the token that we're currently looking at is one of the special tokens that we want to handle. So basically, if it's equal to any part of speech. And if it is, then we can actually do the same thing from before. So if we go back to this get method with the random part of speech and the request and the response, we can just take this code from down here, because we're pretty much using the same thing. If you want to make this cleaner in the future, you can make it a separate function, so you don't have to copy paste code. And we can just replace this part of speech with token. And we don't want to send a response back. So now that we have the token, we can add it to the result. And if it's not a special token, then we can just add it straight up. We don't have to do any kind of additional processing. And then at the end, we can just say return a 200 status code, say that everything worked, and send back the result to the user. So this is the code that we want for our post request. But the problem is, if we want to test this, we can't just open up Chrome and paste in the URL, because it expects some data in the form of a body. So now at this point, we're going to open up Postman. And what Postman will do is it'll allow us to make more varied kinds of requests and get more data about what our requests are actually doing versus just doing GET requests through the browser URL. And when you open this, the first thing that you'll see is you'll just see a blank window, and what you'll have to do is click workspaces and go to your workspace. And to create a new request, you can click new right here and click HTTP request. And if we test that out, for example, we can go to words. We can go to our words endpoint just to see how Postman works. And if we click send, we can see that the data is all returned just how we expected. So now if we want to test our post request, we have to change this get to post. And we have to change this to fill. And if we just send this right away, it's not going to work. because the server is expecting a text field in the body, but we never gave it one. So I'm just going to restart the server here. And what we're going to do is we're going to go in the body and we're going to click raw and create some raw JSON here, where our key is text and the value is some kind of testing string. And now if we send this, okay, so when I sent this post request, it gave the error cannot read properties of undefined. And the reason this is happening is because our server expects things to be in JSON format, but our request never specified what format the data will be in. So what we have to do is go in headers and we have to add a new header here, content type. And you can do that by clicking on key. And then in the value, we need to put application/JSON. And now if we send this with the proper headers, we'll see the proper response here. I like to boogie solemnly using my lovely apple. If we send this again, we'll get something different. And as you can see, our post request is all working as expected. So yeah, that's everything there is for this intro to backend. If you want to know how to access the API you made on the front end, you can check out the intro to JavaScript workshops and the intro to API workshops. And some things that are important to do for the setup here, always remember to put this app.useExpress.json. You need to put app.use cores if you want your website to be accessible, and remember to require express and cores too. These are all essential setup steps. And if you get any of the common errors you get are probably due to skipping one of these things. So just keep that in mind. And another common type of error is if you forget to put the content type in the header, or if you forget to, or if you name the key wrong when you're giving your request. Those are some common types of errors that you should look out for. And yeah, that's everything that I have. If you have any questions, feel free to leave it in the ACM Hack Discord. And have a good time at HOTH.